Hello folks, and welcome to Pythagorean Theorem Day 2. You're probably asking, when will we ever use this stuff, Mrs. Brendan? And I'm going to tell you that this is one of the most widely used formulas outside the classroom. The Pythagorean theorem is used a lot. So today we're going to take a look at applications and how it's used outside the classroom. Yeah, that means story problems. Insert eye roll here. Okay, so what's going to help you is I've given you guided notes and drawing pictures. Drawing pictures helps us visualize the right triangle and what parts of the right triangle I'm looking for. So if you take really good notes and draw really good pictures, you don't have to draw great pictures. I'm a horrible artist. But if you draw a picture so that you can see the triangle, it really does help and you will be a lot more successful. All right, so the first situation is the baseball situation. So on a baseball diamond, the bases are 90 feet apart. How far is the throw from third base to first base? Yeah, you might want to know this if you ever want to find out the speed of the ball. You know, you have to throw it so far, and if you time it, you'd probably be able to find how fast you're throwing the ball. Okay, so here's a diamond. Now I'm going to take this picture and I'm going to look at a diamond in a bird's eye view so that I'm looking up above the diamond. And when I'm doing that, this is going to be my 90-degree angle where I have a first base. This is second base, 90-degree angle, and third base right here is a 90-degree angle. And then I got a 90-degree angle here, and that's my home base. Now, it said that all the bases were 90 feet apart. So 90 feet all the way around. Okay, and then I want to know how far the ball is if it's thrown from third base to first base. So I want to find this length right here. Well, now what I've done is I've taken my diamond and turned it into two right triangles. Now it doesn't really matter which triangle I use, so I'm going to go ahead and use the top part of the triangle. If this is my 90 degree, that is my hypotenuse, and so those two must be my legs. So if I use the Pythagorean theorem, 90 squared plus 90 squared equals x squared. That's 8100 plus 8100 equals x squared. 8100 and 8100 is 16,200. Square root both sides, and I approximately get 127.3 feet. The great thing about applications, we can all be happy about this, is decimals are okay. We don't have to simplify our radicals when we're talking about applications. So it's 127.3 feet. Now, if I wanted to figure out the distance from second base to home base, I'm hoping that you know that we would not have to do the calculation again, as we have two 90 feet distances here, and we would be finding our hypotenuse again. So it would be the same feet. All right, situation number 2. Oh my goodness, I have locked myself out of the house, but I just paid a locksmith to come and let me in. But you don't want your parents to know you locked yourself out of the house, and there's a window open, and it's on the second floor, and it's 25 feet above the ground. So we have a ladder, 25 feet, okay? And you need to borrow a ladder from the neighbors. So you go over to the neighbors and you're like, help me out. I need a ladder, okay? And you have to place the ladder 10 feet away because you have a whole bunch of shrubs here and rock and all that stuff and maybe some trees. So you have to go 10 feet from the house. And then you place the ladder along the side, and you tell your friends, your neighbor, will stay there and hold the ladder for me so I can climb up to my window. Okay, we want to find out if their 30-foot ladder will work. Okay, so we got 25 feet, we got 10 feet, we've got our 90-degree angle, that's our hypotenuse. Okay, we've got a squared, 10 squared plus 25 squared equals x squared. 100 plus 625 equals x squared. 725 equals x squared. The square root of both sides would be 26.9 feet. So it's 26.9 feet from the ground up to your window. Will the neighbor's 30 feet ladder work? Yes, the 30-foot ladder will work. So yes, it will. Would a 20-foot ladder work? Not so much, okay? So that is another application. Okay, let's do one more application. You have some extra money. Oh, look at there. See, there's my ladder. But I wouldn't want to put it straight up and down, just saying. So that's why I put it at an angle. All right, situation number 3. You have some extra money to spend and you're thinking of buying a new television. Your entertainment stand in your room has an 18 by 20 inch spot for the TV. So you got you got an entertainment center. Woo! Here's my entertainment center. I have an 18-inch by 20-inch spot for my TV, so this is where my TV is going to go. I've got some shelves over here. I got some doors down here to store my DVDs and my VHS tapes. You probably don't even know what those are. Maybe some CDs, stuff like that. Okay, so the opening is an 18-inch by 20-inch, and you want to know the maximum TV size you can fit in the stand. Well, what you need to know is how they measure TVs. Okay, well, hopefully, if you didn't know this, you are learning it now, that TVs are measured by their diagonal. So a 28-inch TV or a 32-inch TV or a 56-inch TV, it's measured by the diagonal. So what we want to do is we want to find out what this distance is, this diagonal distance in our entertainment center, so we can find out what size of TV we should buy. So we've got, this is a 90-degree angle. Hopefully it's 90 so that the entertainment center will stay upright, okay? 18 is a leg, 20 is another leg, and then the diagonal is our hypotenuse because it's across from the 90-degree angle. So 18 squared is 324, 20 squared is 400. That equals x squared. 724 equals x squared. Square root both sides. X equals 26.9 inches. Could we have a 27-inch TV fit in our entertainment center? No. And personal story here, I've actually done it and it doesn't work. I had to take the 27-inch TV back and buy a smaller TV. So, real world, most definitely. All right, well, that's it. Hopefully you took good notes and you have some drawings to help you. And tomorrow we will practice some more.